what's the first thing we should always do? We should always substitute in the value. And it's a one-sided, especially if it's a one-sided limit, usually those can be evaluated. This is a one-sided limit, pi. This is yesterday's handout still, or the other handout because they're identical. Blue, and then I gave you a pink one, but it's the same problems. But if you want to practice with them, you can. I was thinking they were different, but they aren't. Okay, so we have the sign of pi. And for those of you who were gone yesterday, we must always substitute in, and if we're going to use L'Hopital's rule, we must show that it's 0 over 0. Okay, Sam? So you evaluate this. What's the sign of pi? If I don't remember, I'm going to draw a little picture. So that's 0. 1 minus, and let's do the cosine. I'll just do it in a different color. Okay, the amplitude's not quite right, but it's close enough. That's pi. What's the cosine of pi? Okay, I'll remind you to put your phones away. You're not very good at that, Eric. So what's 0, not pi, negative 1. What's 0 divided by 2? L'Hopital's rule does not apply. Remember, for L'Hopital's rule, you must have 0 over 0 or infinity over infinity. It must always be written as a fraction. Okay, Zach? Any question on that? Is that okay? You always find your limit first if you can. I don't use L'Hopital's rule unless I can't do it another way. Okay. L'Hopital's rule say you take the derivative. Now, what if we have indeterminate products? And I have a handout for you someplace on indeterminate form. So what if you have a product of two things? Like 0 times infinity. What's 0 times infinity? Maybe that could be better. What do you mean 0? Why is it 0? Zero times any number is 0? Is infinity a number? No. This is tug of war. Bjorn will win, but if we play tug of war, I'm pulling in one direction, he's pulling the other. I'm going to 0, you're going to infinity, and maybe there's a stalemate. Or maybe infinity wins, or maybe 0 wins. I don't know. Let me think. Okay. What about that? What's the limit of e to the x as x goes to infinity? That's 0. As x goes to infinity, what's 1 over x? No, I mean I want x. Sorry. No. 1 over infinity is, no, 1 infinity. Sorry. I had to think. Just a minute. That's what? Infinity. Is the answer 0? Sorry. Let's try this again. We'll start all over. This is infinity times 1 over x. That's 0. Is it 0? Why does it have to be 0? That's the same. That's the same as this. Using L'Hopital's rule, as x goes to infinity, that's infinity over infinity now. Very cool. And since I have infinity over infinity, I take the derivative of this, and the derivative of that, what's that limit? Not 0. It's infinity. This infinity is way stronger than the 1 over x. So 0 times a number is 0, but 0 times infinity is indeterminate. I don't know what it is. So what you have to do is really what I did right there was I wrote this as a fraction rather than a product. So this is, the answer is infinity. If you have e to the x over x, and x is going to infinity, this is going to infinity faster than that one. This is going to win. You have graph it on your graphing calculator. It's not 0. 0 times a number is 0. But infinity is not a number. So while you're getting closer to 0, the other guy's getting closer to infinity. No. You know, Mrs. Hersman said the same thing. She said, my students said, you guys have been lying to us. No, 0 times a number. So I think there may be some sloppiness in how things have been said in the past. Not 0 times anything. 0 times any number is 0. Infinity is not a number. I had that same misconception as well. Well, let's look. Actually, why? Let's look at it this one. Now, you guys, this is the CAD software. We'll do it graphically, and then I'm going to let the CAD do the limit. Okay, so you have your blue sheet out, Trevor. Zach, guess what I'm going to take? At this moment. Then you talk to me about it. Okay, graph. I want e to the x times 1 over x, right? So e to the x times parentheses 1 divided by x. I know too many calculators sometimes. This is the Inspire. Now, I forgot the x. So what I'm going to do? This is now on the iPad. No, the iPhone's too small. The screen is too small. It's going to be Inspire. Why am I not hitting that? Oh, because I'm not supposed to hit that. Then I always forget. I got to do that. Times. Now, why am I doing this on the Inspire? There's a reason for this. Where's my parentheses? Oh, where did the log come from? Okay. You guys, why are you so loud? There it is. As x goes to, notice what happens as x goes to negative infinity. That's a totally different answer. Okay, Nick? Now, what I can do with this, even more so, is I can now, and you can do this with the app as well on the iPad. It'll be just like this. You just touch the iPad like this. And I'm making the y's go big, and the x's are going. What do you think? It may not quite be in the App Store yet. I don't know, but the. What do you think? Okay, guys, that was 0 times infinity. Do you believe it? Guys, this first one was all done with this yesterday. I'm still working on it. So, but now let's add a page. And you can have all the TNS documents you want. Let's do a calculator. And we're going to go into menu. Now, this is the cast. If you have an iPad and you can't use it on a standardized test anyway, you might as well get the cast. It's the same price. It's $30. We're going to go to calculus. You do exactly what I'm doing. We want to do a limit. And we want x to go to infinity. Now I got to find it. You don't. Now, well, we know that. We did it on the graph. I was just going to show you this. Let's see if that doesn't give me. There it is. So the CAS calculator will do your limits for you. It's really kind of nice when you get into polars because the answers on polars don't always match the answers in the back of the book. And this is an easy way for you to check your work. Much easier. Okay, and so I don't know who's got a CAS in here. You do? No, Grant does. But it's $30 if you have an iPad, but they don't have it for the phone, unfortunately. But it does all this stuff for you. I see. So I personally like the Inspire better. Okay, you guys, you guys, this is your time. I don't want to get your little quizzes great because I haven't done them yet. But that's a product. I don't know. I try to get rid of that. There we go. Okay, I'm not going to talk over you because it hurts too much to talk. We will once I get to how to do the problems. Okay, guys, if you're not interested, it's your decision. But let me tell you, this test is not going to be easy when we do the L'Hopital's rule. This is a product, okay? How are you going to do a product? L'Hopital's rule only says it only works for fractions, 0 over 0, infinity over infinity. I have to write that as a fraction. Okay, Zach, how am I going to write this as a fraction? There's a couple ways you can do it. One is easier than the other. That won't work because the derivative of 1 is what? 0. Why don't we do this? Does that work? You guys are a BC Calc. You should be able to see this quicker than others. I couldn't hear you. Okay, you usually do. Now, what should you do first? No? Take the log of 0, which is negative infinity over what? 1 divided by 0 is infinity. Still infinity. Infinity over infinity, be it plus or minus, is still qualifies for L'Hopital's rule. 1 divided by a very small number is going to be bigger and bigger because this is 1 over 1,000 and this is a reciprocal, so it's 1,000. Use your calculator. So now that I've gotten to this point, I wrote this down, and on the exam, if they throw this at you on this pre-response, you must evaluate your limit. I don't care what kind of, even if it's not L'Hopital's, you still put it in there. Okay, and I want the limit as x goes to 0, and I want the derivative now of the log of x. 1 over x. And what's the derivative of 1 over x? Negative 1 over x squared. Okay, what are we going to do to get rid of that complex fraction? Multiply by x squared over x squared. Works for me. You always must simplify. So this is going to be the limit as x goes to 0 from the right-hand side, and this is x over negative 1. Oh, there we go. And I'll use L'Hopital's rule again, not unless when I simplify it, it doesn't change. But it did change. What's this limit? It's 0. Again, this was infinity times, it was 0 times infinity, 0, 1 out. Log grows really, really slowly. The log of 100 is like 12. So if you have, this is going to 0, and that's going to get bigger and bigger. Even the log of 1,000 is like 100. That's going to go to 0 much faster than that gets to infinity. So 0 wins. That's why they're called indeterminate forms. I could have multiplied by x. It doesn't matter. I just chose the biggest denominator to make it simple. If I multiplied by x, which I can multiply by whatever I'd like, actually. Then I get the limit as x goes to 0 of 1 over negative 1 over x. Well, I don't like that. You like that? Yeah. Well, it's the same as I got over here. So if I did x squared, I got there faster. But it doesn't matter. Okay. Okay, Zach, we have to do differences, and we have to write them always as a fraction. If you can remember that, L'Hopital's rule only applies to fractions. So here's an example of one that's a subtraction problem. Can I write that as a fraction? Sorry. David, how am I going to write this as a fraction? Everybody should have their notes out. You should be doing the problems with me because I'll remind you, we do not give retakes. And this is a tough section. And I know I've seen these problems done by students for many years, and they struggle on the L'Hopital's rule. You might think it's easy, but it's not easy. Okay, so how am I going to write that as a fraction? Eric might help you too. I don't know. Why is it 1 minus sine? Why don't we do things in order so that everybody can see what we're doing? What's the secant? 1 over cosine minus. Now, if it had been cosine of x over sine of x, then you would have to get common denominators. We already have a common denominator, which makes it so much easier. So we will combine our terms there. We'll simplify that. We have common denominators. So it's 1 minus the sine of x over the cosine of x. Before you use L'Hopital's rule, you still better show me 0 over 0, or infinity minus infinity, or whatever. So that's 1 minus the sine of pi over 2. You guys know what that is? So the net result is 0, so you got lucky. And what's the cosine of pi over 2? It's 0. Okay, so now we can use L'Hopital's rule, and this is easy. They aren't going to be as hard probably on the exam. I would also do that. They said it wasn't necessary when I graded that problem to write the L, but you know we have a new chief reader. We have new question leaders, so I would write it. So the derivative of minus sine is minus cosine. I ignored the 1 because what's its derivative? What's the derivative of cosine? Negative sine. Do you remember the derivatives of all the cofunctions are negative? That'd be cotangent. Why don't we just evaluate it? You could, but I don't know what the value of the cotangent of pi over 2 is. So let's just evaluate it at pi over 2. So it's the limit as x goes to pi over 2. From the left, it's the cosine of pi over 2. And it's minus the sine of pi over 2. That's easier. This is 0, and that's negative 1. Oh, I'm sorry. That should be positive. Although it won't matter because the answer is what? It's not. No, you don't do it again. Do you have a value? Two negatives make it positive. So it's 0. I will be getting the Inspire app so that you can use my Inspire app on my iPad, but I only have one iPad. So if you ever want to borrow it in class, it's fine. That would be nice. Okay, you guys, I printed this out for you. So you've got them all. Here are the different types. 0 to the 0, infinity to the 0, 1 to the infinity. I know that seems 1 to a number is 1, but 1 to infinity, not necessarily. And we're going to figure out how to do this in a second. Because you're going towards 1. Remember this limit? Is that right? When h goes to infinity, this is going towards 1. You might say it's 1, but 1 to the infinity is integer. No, it isn't. This is e. We found a place in between. If you don't believe me, I can bring up my cast. Why not? Now it would be interesting. No, they won't do it on. They won't do it on a computer. Okay, I want a limit, and I don't know where they have all this stuff. Let's see. We used h. So let's use h because I can. Much easier than the 84. Now the new 84 is in color. If you want to stay with 84. No. On the iPad, yes. And what was this? There. Cheat. Okay, it's parentheses 1 plus 1 divided by h. Should go into pretty print for me. And then we're going to raise that, where's my caret, to the h. I could have used x. I used h in my example. There it is. Oh, as what? Yes, but that's not what that indeterminate form is about. That will be, well, we can try it. Now, you know you can go back up here and copy it if you didn't. But that when they do the 1 to the infinity, it means the one function is going to 1 and the other function is going to infinity. Like in this example. That's what that means by indeterminate. See, it says the limit is 1, not the value of the function. Right. Good point. I like that question. Okay, here. No, put it away. 3 times and you're out, kiddo. Okay. Let me see if I can find my handouts. They were blue. And this is my cast you can always borrow. So what are you going to do with this one, you guys? I can tell you right now there's a problem on the test just like it. They're AP questions. So they're not as hard as the book, but that doesn't mean they're not hard. Then I told you what to do with these. Hey, Kim, I need to do the hardest problem here. Okay. Nobody has an idea what to do with that? Remember, L'Hopital's rule only works for fractions. I need to make that a fraction. So what I'm going to do is log both sides. Because if you try to put in 0, you get 1 to the infinity, that indeterminate form again. Okay, so the log of y. Now what am I going to do with this? Yarn, what am I going to do with that? So it's the cotangent of x. That's okay. Okay. I'm not going to worry about the left side, but I want the limit of both sides. So I'm going to take the limit and let x go to 0 from the right, and the limit as x goes to 0 from the right of this. But again, I don't have a fraction. But now it should be easier to write that as a fraction. No? I don't want to do the log. I want to do the cotangent. Well, how is cotangent related to tangent? It's the reciprocal. So if I put cotangent in the denominator, it becomes the tangent. This is not the function. This is the log of the function. Because it always has to be 0 over 0 or infinity over infinity. So I wanted to get rid of that exponent. It's a trick. I want to use L'Hopital's rule because I don't know what's the... So I took the log. It's just a trick. Now, what happens when I put in 0? What's the sign of 0? It ends up being the log of 1, which is 0, over the tangent of 0, which is 0. 0. So you can use L'Hopital's rule. We're still left with the limit on the left as it is. Okay. So it's 1 over 1 plus the sine of 4x times cosine of 4x times 4. That's the denominator. That's secant squared. Is that okay? Now, if you remember from yesterday, anytime you have a cosine of 0, it's not a problem. I don't want to take the derivative of that thing yet, and maybe I don't even need to. Because let's go ahead and put in 0 right away and see if we need to even simplify it. If I put in 0, it's 1 plus... if I get a number here, then I don't have to simplify it. I could have. It's 1 plus the sine of 0, but that's 0, times 4 cosine of 0 over secant of 0 squared. The only problem is if I get 0 over 0. Do I get 0 over 0? No. What is this? What's the secant of 0? It's 1. Because it's 1 over the cosine of 0. Okay, so this ends up being 4 on the right side. On the left side, we have the limit as y goes to, was it 0? You can help me out. Was it infinity or 0? 0. You got it right there in your sheet. And it was the natural log of y. Now, when I take the limit of the natural log of y, does that affect anything? If this is not y going to 0, but x is going to 0. Does that do anything? What's the limit as x goes to 0 of 9? That's 9. So what's this limit going to be? Not y itself, but the natural log of y, which is equal to 4. Yeah, but some people said the other way. I heard both. When you take the limit as x goes to 0, that doesn't affect the log of y. It would affect the log of x. I don't. I know that the limit of the log of y is equal to the log of y. And on the right-hand side, I got 4 using L'Hopital's rule. So how do you find y? This is the way I do it. E to the 4th equals y. And that's the answer. But I'm going to do questions on homework. Where's your phone? Where's your phone? You can use my iPad. Okay. I don't know what time it is. What about questions on 4-1? Anybody want to present anything? Or you have questions that you want to ask me? I don't care. I haven't done them in a year. We have a lighthouse, and it's rotating at 4 revolutions per minute. So it's moving pretty fast, actually. And at an instant, we are up in a helicopter. Here's the shoreline. The light's going to go there. I don't know if you can see the yellow, but the light's going to be there at a particular instant. And at that instant, I'm actually going to take my picture, and this is going to be 1 kilometer. But at the moment, I'm not going to put it down. Well, we need to do a find, give, and when, right? Okay, what is it I'm given? What's 4 revolutions per minute? Revolution is the change in the what? The angle. Now, the problem with that is I must be in radians. So d theta dt is equal to 4 revolutions per minute, and we'll change to radians. 1 revolution is how many radians? Trevor, how many? 2 pi. So d theta dt is 8 pi radians per minute. You must be in radians. So that complicates things. Then I want to know how fast the beam is moving down the shoreline. Matt, what do you want to call this distance? I would have called it X, but that's okay. I'll work. Okay, guys, ready? Is that what? Yes. You are looking down. And you're going to take a picture of this. If you could, if you could see that beam of light that's here, you would take a picture and you would see this triangle. So I want to find how fast this light is moving down the shoreline. It's doing this. It's moving. So what do I want to find? John, what do I want to find? The LDT. Now, you guys, usually you get a point in the AP exam for your given, or something in the find given, usually not the when, might be in the find even. Who knows? It's usually in the given. And it's the when. And when is it? When is, what's that distance? 1 kilometer from point P. So what's 1 equal to? L. Okay, Michael? The secret to doing these, there's a secret to related rates. If you look right here in the given, and I have my angle, and I have L. So I want to relate the angle and L. I don't want to use Pythagorean theorem, because it's not Pythagorean theorem. I want to relate the angle and L, and I know that. Which trig function? Tangent. So the tangent of my angle is equal to what? L over 3. You could solve for theta, but that's too hard. Why don't we just take the derivative? Do it implicitly. It's much easier. Isn't it? What's the derivative of the tangent? Secant squared of theta times d theta dt. You better get a d dt on both sides, no matter what happens, is equal to 1/3, that's 1/3, right? Times dl dt. And what is it I know? I know L is 1, which tells me nothing. And I know d theta dt is 8 pi. So I need to know the secant of my angle. So you know what I'm going to do? I'm going to draw the picture. This is 1. Now this is the snapshot. This was how big? 3? Pythagorean theorem. 3 squared plus 1 squared is, what's the secant of my angle? Cosine is 3 over the square root of 10. Secant is n is the square root of 10 over 3. So I don't mess up, I'm going to actually write it out. Squared times 8 pi equals 1/3 dl dt. I needed the L to get the secant, but it doesn't factor into the direct equation. And so then we just square that. So that's, that's 10 what? 9th times 8 pi equals 1/3 dl dt. So what do I do to both sides? Multiply by 3. And I can reduce that just because I want to. But normally, if this were free response, just leave it even the way I have right now. Good enough. Now, this problem would not be a free response. It would probably be multiple choice. And it could be in the calculator section besides. Probably would. So I've got 80 over 3 times pi. Hope that's the right answer. Is that the right answer? Well, you have your solutions open. Oh, okay. Were you okay with the pool? That's the pool. Yeah. Which number is that? 27. 27. A trough is 10 feet long. And it says the ends have the shape of isosceles triangles. Yeah, I think a picture would have been nice for this. triangular prism? Don't copy it. You need to do it.
Well, I know it. I found an error actually.
Possible.
A local max. Positive, negative, positive.
Ah, see? Okay. Let's take a picture of this end here. It's isosceles. You guys know your geometry? If this is 3 feet across, this would bisect if I'm trying to avoid fractions, so let me read more. And it has a height of 1 foot. The water is going into it at a rate of 12 cubic feet per minute. 12 cubic feet per minute means what? dV/dt. Okay? Matt, you know how to do this one? Yeah, you might want to pay attention. Okay. And then it says, how fast is the water level rising when the water is 6 inches deep? Is that okay to leave that as H? So we want to find how fast that's changing when H equals 3. Okay, so the water's coming into this, and you're going to have a water level here. So this is my water level. Well, I like the old problem. The old book it was harder. But anyway, this one's still not that bad. That's changing. This is changing, isn't it? And there's H. What do you want to call this length? Okay. So X is to 3 as, do I know that? H is to how tall this is. I think I know that, don't I? Oh, it says 1. Now, that's 1 foot. So this is how many inches? Because we're going to be in inches. No, no. It's 1 foot when the water is 6 inches deep. Somebody told me the wrong number here. 6 inches deep. So 1 foot is 12 inches. You got to keep your units consistent. No. This is 1 foot. Oh, you're right. These are 3 feet. Thank you. That wasn't inches, right? Okay. Now, I want to relate V and H. What's the relationship? How do you find the volume of a triangular prism, or any prism? It's the area of the base times the height, right? But what's the base? It's that triangle. So capital B, and I like to simplify everything, is 1/2 the base times the height. Looking at my picture here, what's the base of my triangle at any given time? It's changing. We call this length X. You can't use the 3 or whatever number it is up there. So it's X, and we call the height at any given time H. So substituting into my formula, because I haven't looked at this for a while, so I'm just doing the problem. It's X times H, and what's the big length? 10. So V is equal to 5 times X times H. A lot simpler than what it started out looking at. Like. But I want to relate H and V. So which one do I want to get rid of? I want to get rid of X. So I'm going to use this relationship I have right here. Can I find out what X is? What is X? So multiplying by 36, I get X equals 36 divided by 12 times H. So X equals 3H. Now can I slide that? So X is going to be equal to 3H, so I'm going to substitute that in there. Still no calculus. The volume is equal to 5 times 3H times H. Now, the units are correct. This is cubic, because this is square, but the 5 has something to do with the length of the trough, which is not changing. So I do have cubic feet. H squared, and now this is easy calculus. I want d what? dv dt is given, I want dh dt. So let's take the derivative with respect to time. Sometimes change color. Yeah, hopefully you go faster than me. So dv dt equals 30h times what? The h dt. You will always get derivatives on both sides. And dv dt, if I go back, was 12. Oh, wait, that's cubic feet. I may have to watch my units a little bit. We were in inches, weren't we? How many cubic feet in it? How many cubic inches in a cubic foot? This is 1 cubic foot. So it's 12 times 12 times 12. So that was, how many cubic feet was this? I almost didn't catch that. That's 12 cubic feet. So it's 12 times 12 cubed, or 12 to the fourth, equals 30. And what's h? I'm in inches, right? Times 6 times the h dt. So it's 12. Honestly, I would take a calculator out. I could work it out, but it would bother you. Did you see the similar triangles here? You will see similar triangles on the exam. So do you see the similar triangles? This side is to the whole height, as this is to that. I don't think they'll mix up units on you like they did on this. That would make it hard for us to correct besides. And what are they testing? That's the next question. What's your goal here? What are you going to test? Testing the can you solve a related rate problem, not can you worry about the units. Yeah, that would be in the physics exam. Not so much in this one. I do have an IEP tomorrow morning, but I am here. I'll be here. I have to go to the meeting. It's legal, it's law. And then I'll be back.